Let us look at proposition number 31 of works of Archimedes, specifically from book 1 of On the Sphere and Cylinder. The proposition says the solid of revolution circumscribed as before about a sphere is equal to a cone whose base is equal to the surface of the solid and whose height is equal to the radius of the sphere. So let's see what this means and how to prove it. Given a sphere with a circumscribed polygon of 4n sides, let A, M, A prime, M prime be the great circle of the given sphere. The polygon produces a polygonal solid on being revolved about A prime. So let's produce that. Now, the proposition is saying that the volume of this polygonal solid is equal to the volume of a cone with base equal to the surface of the solid and height equal to radius of the sphere. Here, the trick is to realize that this polygonal solid is circumscribed on the sphere, but we can always circumscribe a sphere on this solid so that this solid becomes a inscribed solid, inscribed in a larger sphere. So the circumscribed polygonal solid is an inscribed solid in a larger sphere. So let's draw that sphere. Draw OP perpendicular to AB. AB is one of the sides of the polygon and it is touching the inner sphere at a point. Let's say that is P. We draw a line perpendicular from P. So now OP is perpendicular to AB. So which means that OP is equal to the radius of the given sphere. And based on proposition 26, we can say that the volume of the polygonal solid is equal to the volume of a cone with base equal to surface of the solid and height equal to radius of the sphere, because OP is the radius of the inner sphere. Just for making sure you understand, OB is the radius of the outer sphere, but OP is the radius of the inner sphere. The proposition is proved. But there is a corollary to this as well. The corollary says that the solid circumscribed about the smaller sphere is greater than 4 times the cone whose base is a great circle of the sphere and whose height is equal to the radius of the sphere. Now, let's take it step by step. Describe a cone P with the base equal to the surface of the polygonal solid and height equal to radius of the inner sphere. So here we have the cone with base equal to the surface of the polygonal solid and height is equal to, it is equal to the radius of the inner sphere, OP. Remember, we have already seen how to draw a circle like this, because we know that the surface of the polygonal solid is equal to what? Square root of AB times the sum of B prime, M prime, Y prime. Now the next step is to describe a cone Q with the great circle of the smaller sphere as the base and height equal to the radius of the great circle. So let's do that. So now what do we have? Volume of cones are proportional to their bases if the height is same. And here heights are same because the radius of the inner sphere and radius of the great circle, they are the same. So since the heights are equal, the volume of cones are proportional to their bases. So that means volume of cone P is to volume of cone Q is equal to the base of P is to base of Q. Earlier we have seen in proposition 30 that the surface of the circumscribed solid is greater than 4 times the great circle of the inner sphere. Volume of cone P is to volume of cone Q is equal to base of P is to base of Q. But what is base of P? Is the surface of the solid. Base of Q is the great circle of the inner sphere. So, volume of cone P will also be greater than 4 times the volume of cone Q, since surface of solid is greater than 4 times the great circle of the inner sphere because of this proportionality. But volume of cone P is what? Is the volume of the circumscribed solid. So volume of the circumscribed solid is greater than 4 times the volume of the cone Q, which has the base as the great circle of the smaller sphere and height is equal to the radius of the great circle. We have looked at the proposition number 31 and its corollary from the works of Archimedes, specifically from book 1 of On the Sphere and Cylinder. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now. Bye.